Find the positive root of the equation f of x equals x squared minus 2 equals 0. Start with the initial guess x0 equals 1.5 and round each step to 6 decimal places. Using the Newton's method, we use a formula xn plus 1 equals xn minus the function at xn divided by f prime at xn for n equals 0, 1, 2, 3, and so forth. For the function f of x equals x squared minus 2, we know this is a parabola with the y-intercept at negative 2. We're gonna have the two x-intercepts, but the initial guess x0 equals 1.5 will lead to the closest root, so we will not get both roots at the same process. As x0 equals 1.5, we're gonna need the f function, the function value at x0 and the derivative at x0. For x0 equals 1.5, the function value at 1.5 is 0.25, and the derivative at 1.5 that we're gonna have to start with what is the f prime. The f prime is 2x, therefore the f prime at 1.5 equals 3. Then we compute the x1, which is the next the first approximation. So x1 equals the x0 minus the function at x0 divided by f prime at x0. x0 is 1.5. The function at 1.5 is 0.25 divided by the derivative at 1.5, which is 3, give us the number 1.41667 for 6 decimal places. And next we use x1 as 1.416667 and the function value at x1 together with the derivative at x1 to find the x2 value. So x2 can be computed by x1 minus the function at x1 divided by f prime at x1. So the function value at 1.416667 is 0.006944, and the first derivative is 1.414216. Plug it in the formula of x2 as 1.416667 minus 0.006944 divided by 1.414216 gives us the value 1.414216, and keep doing the same way to get the next approximation, which is x3. F of x equals x squared minus 2, and the derivative is 2x. So f at xn is xn squared minus 2. The f prime at xn is 2 times xn. When x0 equals 1.5, the function at 1.5 is 0.25. The derivative at 1.5 is 3. Compute to get the first approximation x1. Using x0, we get 1.41667 and use x1 to find x2 for the next approximation. So the function value for x1 is 0.006944. The derivative is 2.833333, and the next approximation x2 is 1.414216. Use x2 to find x3 for the next approximation. The function value at x2 is 0.000, the 5 zeros, and then 6, and the f prime is 2.8284331. To get x3 using x2 and the function and the derivative at x2, we get x3 as 1.414214. As x3 equals 1.414214, the function value at x3 is very small number. So this is 4.51 times 10 to the negative 12. And the derivative is 2.828427. Compute to get x4 as 1.414214. As the last two approximations have the same number, so we stop the process at this step. Then the x-coordinate or the x-intercept or the root of this function is x equals 1.414214, as we can solve analytically for this problem as x squared minus 2 equals 0. One of the root is positive square root 2, which is positive 1.414214, which is the one that closer to the x0 1.5.